All right. So, welcome to another episode of our Maple webinar series. And this is an ongoing series. We did quite a few in 2020, and this is our 2021 series. Tonight, I'm going to be talking about Sugarbush inventory methods. And the funding for this work and this whole series is through a USDA AMS ACER development grant. So we thank them for their support. Like I said, we have more webinars to come. Tonight, we're talking about Sugarbush inventory. In 2 weeks, we have Chris Lindgren talking about SAP-only enterprises, if you're really focusing in on the SAP production and less on the syrup production aspect of maple. Then we get into some binding contracts and legal agreements. On October 13th, we have Tony D'Amato talking about maple forests and forest carbon, which is an interesting topic. And then we have forest land taxes and tax abatement programs at the end of October. And we're probably going to be adding some more dates. That has not been firmed up yet, but got a good slew of topics to come. So, assuming there's no other issues or people have any problems technically, please just put those in the chat and we will get right to it. Otherwise, we're going to get started. Like all good presentations, got to start with a little bit of background or introduction. And so the question is, what is an inventory? And this is not unique to forestry, but in the context of this presentation, it's a way of measuring and recording something of interest. We're talking about taps primarily, although we'll be talking about maple trees in general, but you could easily have an inventory of all the wetlands on your property, or you could have an inventory of all the interesting archaeological sites in and around your area. You could have an inventory of all the culverts. It's just a systematic way of measuring something of interest. Taking stock of what you have currently is really important for planning future activity. So it's really important to have good ideas and data on what you have, and it's really the only way to go forward with a good plan. Probably not a surprise to hear that an inventory often involves some sort of estimation. In other words, we're taking a small sample and trying to use that data to represent the larger property or the larger region or whatever you're inventorying. Time and money, there's just no way you can measure everything once you get to beyond a certain scale. Along those lines, time and money, you can certainly do what we're talking about tonight yourself, do a little DIY inventory. You could also hire a professional forester, and much like putting the siding on a house or doing some concrete work, you could probably do it yourself. Sometimes it might take more time and more money than you thought, and hiring a professional is often well worth the money. So consider a professional forester who's trained in this type of work. Why you would do it, we've already talked about a few of the reasons why. Another way is just a basic engagement with your property. If you're accustomed to really just walking around a certain part of your property, doing a systematic sample of your entire property allows you to see your property from a different perspective. It allows you to engage differently with your whole parcel. From a business side, having a good inventory of what you have for tappable trees is really important for estimating tubing installation costs. It's also important if you're looking at a potential property. Say you have excess capacity in the sugar house and you're interested in a new property to lease or to buy. You want to have a good idea of what you have for tappable trees there to get quotes on materials from tubing manufacturers. If you're hiring a tubing installer, you really want to have a good, accurate number of what that's going to be. I've heard certainly plenty of stories of people saying, yeah, I think I've got about 1,000 taps maybe in this woods. When they actually get into the business of going out there and starting to lay things out, sometimes it's 2,000, sometimes it's more. There's time and expense associated with that. Sometimes pricing is better if you hit certain thresholds. So keep in mind that beyond just knowing how many taps you have, it's important in terms of cost of installation of tubing. It's also important to understand the general health of trees, what you have for regeneration, and really what the general average diameters are in your wood. So we'll talk a little bit about why that's important. The health and regeneration, typically, if you were just trying to figure out how many taps you had, you may not record that. A forester may use that in terms of a larger forest inventory. It really depends on what your goals are and what kind of information you're looking to collect. The simplest would be just a simple tap count. How many trees are there that are of tappable size right now? And compared to maybe a more complete or intense inventory that would involve not just tappable trees, but site quality, soils, and lots of other aspects. It's also important to know, what's the state of the forest? Are you in a very young stand that's really just becoming a small pole size? Is it intermediate? Is it more old growth? Has it had very little management over time? Was there a large harvest recently? All these things can be important as you're planning a future tubing system or expanding an existing one. So again, this would be issues that would come up if you were hiring a forester to do a full forest inventory, or if you were looking to do it yourself. Information you'd want to record as you're going through checking on the number of taps you had. You'd also want to be including something about what's the structure or the age of the stands you're in. And why does tree size matter? Well, we know from previous research, not just at UVM but elsewhere, that the size of the tree really matters in terms of how much sap you get. And it's a fairly linear, although it's not perfectly linear, relationship. Larger trees will produce more sap. And I've also, talked with sugar makers who at first estimated they had, say, 10,000 taps, but when you actually went out and looked at the inventory data and looked at the trees they were tapping, their abundance of small trees being tapped really meant that they were overestimating how much they could get. And this can have a real impact if you're working with a lender to get money to do this layout, and your yields are based on a certain amount of sap production per year. If you're calling every tap estimating it's going to have a certain yield, if some of those taps or a good proportion of those taps are in small trees, you are probably never going to hit that estimate. And within the forest, not all stands are the same. Some stands have a higher proportion of small trees, and some of them it's a little bit heavier to larger trees. So knowing that distribution of diameters is really important. And this is a classic inventory technique that is used in forestry. If you're growing trees for timber production, foresters need to know what diameter classes have how many trees. So this is really helpful in terms of yield as well. We are currently working on an online calculator that would allow you to enter some of this data by diameter, and you'd get some estimate based on how many 10-inch trees versus how many 20-inch trees, and so on, how much sap you could realistically expect to produce. Another interesting difference in inventory is the distinction between plots and points. And we're going to spend a lot of time a little bit later on in this talk teasing out the differences between plots and points. But the important thing to remember is the number of sampling places, be they plots or points, is really going to depend a lot of time on how variable those stands are. If you have a perfect uniform stand, they're all the same size, you really don't need as many to take as many points or plots as you would if there's a lot of variability between different stands. So we'll talk about that a little bit. If you were to establish permanent plots, that can also help you in terms of understanding if any forest management activities you are doing are having the desired effect. So forest management plans often will suggest a certain amount of management over time. That might involve vegetation management, removing trees, thinning. If you have permanent plots, it's a good way of knowing if those prescriptions are having the desired effect. So one sort of rule of thumb is looking for an inch of diameter growth in 10 years. That's good growth. It's not fantastic growth, but it's a good thing to shoot for. And it's also important to know how many small trees that are too small to be tapped, are sort of in the pipeline. How many are going to be available to tap in maybe the next round of retubing. So if you replace your laterals on a 15-year interval and you have some trees that are in that small 7-inch, 8-inch size class, if you know that they're coming, it might be a good way or a good tool for deciding when you're going to retube an area. Also, understanding the density of taps in certain parts of your property, it might identify areas where it's really just not worth it to put in a conductor system or even just a main line and laterals, because the tap density just aren't worthwhile. So on the right here, you see a map, just kind of a heat map in a way. This was produced by a company that was marketing a large property. This property was 2,300 acres. They divided it up into 4 stands, and over those 4 stands, they took 425 inventory plots. So quite a few plots that would have taken a while to do. That averages out to be about 5.5 acres per plot. And we'll talk a little bit about why you may or may not want to have that many acres per plot. Another interesting thing, or something to keep in mind when you're measuring the taps, is if some trees have significant defects. Here's a drawing and an illustration done by George Buzzell, who was a county forester in Vermont, and he really wanted to get people's attention thinking about not just a tree as a tap, but as almost a tapping shell. So there's conductive tissue there. If part of that conductive tissue, a significant part, is damaged in some way or unusable, you really want to reduce what the sort of functional DBH or diameter of that tree is. So this is the kind of detail that could be included if you have a large proportion of trees that have significant decay or other damage. That would also reduce the sort of the functional, the actual number of taps or the size of those trees that you would tap. Just another example, sugar maple borer is something that could take a significant part of the tree's conductive tissue sort of off the table. So if you had a stand perhaps that had a really significant outbreak of something like sugar maple borer, something else that impacted the conductive tissue, you'd want to be able to capture some of that information in your inventory. Another interesting reason why you would want to do an inventory is to see where the tubing system would be. Going back to that slide with the heat map, some areas have more dense collection of tappable trees. So you might, if there are obvious patterns to where those trees are, that's going to influence where you're going to put your conductor systems, where you're going to put your main lines. This process will also allow you to get a better idea of what the road system is. There might be some legacy roads that were put in a long time ago, even before your ownership, perhaps. Legacy roads often get a bad rap because they weren't necessarily put in with water quality and long-term use in mind. So if it's an old skid road that was essentially just went right down the slope and has perpetual issues with erosion, these are the kind of roads that that could be improved, or really even just put to bed and abandoned, and in exchange for something that maybe is easier to travel on, less prone to erosion. All these things will come up when you're doing an inventory and checking the entire property. And in case my abstract drawing is throwing you off a little bit, this sort of polygon is meant to illustrate just a generic forested property, and hopefully those green puffy things you can identify as trees, and the blue squiggly lines would be theoretically where a main line might be set up. When you are collecting this data based on stands, you're going to find a very variable amount of taps per acre, and there are pros and cons. Of course, a lot of folks might think that the highest number of taps per acre is always the goal, but the issue with that is that trees are plants and they're limited by sunlight, water, and nutrients. But sunlight is a huge limiting factor. So when you have too many trees in one area, they're not optimizing their growth. And so you would potentially run out of tappable wood. You are stunting the growth, and we know from previous research that smaller trees typically will have less sap on a per year basis. So remember that it's not just maximizing the number of taps per acre; it's maximizing the yield per acre and also the growth over the long term. There's a huge range. I mean, you can have sugarbush stands that have less than 20 taps per acre. You can have that have more than 100, and everything in between. Generally speaking, 50 taps per acre is considered good. If you drop below that 20 per acre, it's really kind of considered not ideal. It's not enough sap production in a given that growing space. So it could be that it's not an ideal maple site. It could be that past management has removed, the tappable trees, and it's really in a regrowth phase. There's a lot of reasons why you might not get too many taps per acre. The old model for sugarbush management, the really, really large, decadent, large crown, widely spaced, almost open grown trees, there are still sugar bushes that fit that model. It really was more of a function of how sap was collected, gravity collection, buckets, needing access to the understory for sap collection. Big trees, big crowns definitely produce more sap and generally sweeter sap, but it probably does not maximize your yield per acre to have that as your goal. The other issue with such a few number of trees per acre is the replacement, the lack of regeneration or lack of ingrowth of small trees. So that's something to also consider. Of course, mapping is really important whenever you're doing any sort of inventory. You want to make sure that you know the property that you are using, either it's your ownership or it's the property that you're leasing. It seems kind of simple to say, but you really do want to make sure that the property boundaries are known. Here's just a screenshot of some parcel data, also known as tax map data. These are not surveys, so they don't represent a careful survey of the property. They give you an idea of the general shape of a property, and there's a lot of great information. It seems like every year there's more and more free mapping information out there, free GPS tools. Our phones are as powerful as really any GPS you could really need for this type of work. So we can't go into all the detail about what's available, but just know that everything from Google Maps to Avenza, which is helpful because it's offline, you could download the maps and use your phone's GPS. And then a lot of towns have this municipal parcel data available, and it can be helpful. You can zoom in. Although I don't know if anyone would recognize the shape, but this is the Proctor Maple Research Center property that I've zoomed into, and you can zoom in even more. That's the lab on the right and the sugar house on the left. And this is all free. This is something you can play around with at home and get a sense of, if it's not your property, if it's a property you're thinking about leasing, get a better sense of where the roads are, where things are at. Is this really going to be worth my time before you even invest in doing an inventory? So let's just assume that you have a property, a sugar bush, and you want to do some inventory. So you have some choices to make. First of all, the sugar bush is part of a forested property, so there are going to be trees involved. It's either going to be owned by the operator, or you're going to lease it and have an agreement with the landowner. I will put a plug in for our Sugarbush lease guide and checklist that can work through the process of developing a Sugarbush lease, negotiating a price. All that information is available on maplemanager.org. we've worked with attorneys, so it's a good solid document to use when you're negotiating with a landowner if you're going to be leasing. A lot of sugar bushes are leased on a handshake, and that's great. There's a tremendous tradition of that. Unfortunately, they don't always work out, and for the protection of the landowner and the operator and all the investments there, it's a good idea to have something in writing. So consider looking at those resources on maplemanager.org. Larger properties will often be enrolled in some sort of tax abatement program. In Vermont, it's the use value appraisal or current use program. Other states have similar programs. A lot of times, part of the requirement is that there's active management that's based on a forest management plan that a professional forester has written or at least signed off on. So if that property is yours, you already have a forest management plan, you often will probably already have this information about the property and the stands. And in case you don't, you want to make sure you know what the property boundary is. If there is some evidence, but it hasn't been painted recently, the property boundary, make sure you know the rules in your state about who can and who cannot refresh paint blazes. In some states, foresters can do it. In other states, they can't. It has to be done by a professional surveyor. So you really want to make sure you know what the property extent is before you start measuring trees for potentially tapping. The other important thing to do is to break the property up into stands, and stands are really just areas of similar distribution of trees. So you might have a stand, like say, that has mostly small trees. Maybe it was most recently a farm field and has been abandoned some time ago. Tree stopped being mowed, trees grew in, and it's progressing towards a later successional or shade tolerant type species. You might have another stand that has been in forestry for a long time. It's really well managed. It's really been maximizing the growth. Those two stands are going to look quite different, and it's often a good strategy to divide those into different parcels so you can understand what's there and manage them accordingly. There's no set rule for how many acres you would have to make a stand. It's probably on the order of several acres there would be a minimum for a stand. You wouldn't want to have a stand that's 1 acre, maybe 10 acres, maybe 20. It really depends on the larger size of the property and then how much variability there is, how many different types of features are there and what the characteristics of the trees are in the stand. So that 2,300 acre property I showed you earlier, I think that had 4 stands. So that gives you a sense of you don't have to have 1 million stands just because it's a really large property. They can be fairly large, and they're generally based on site quality, hydrology in some ways, and structure. It can be done on structure of the trees. So let's talk a little bit about what types of inventories you might do. The first off is the 100% inventory. That's measuring every single tree. And you might imagine this would take the longest. It's not the most practical, and definitely not practical when you get above a couple of acres. It's just going to take too long. So if you're on the hobby side of things, I think that's certainly a possibility. But once you get to be even just a little bit larger, it's going to be impractical to measure all those trees. The next type of sampling is called plot sampling, and that's essentially envisioning a circle of a known size and distributing those circles across the stand and across the property, and taking a measurement within that plot and then multiplying by whatever size plot you used. So here I gave you 3 examples of different plot sizes. A 1/5 acre would have a radius of 52.6 feet. A 1/10 of an acre would be 37.2 feet. And a 1/20th of an acre would be 26.4 feet. So you can imagine putting a stick in the ground, maybe hanging a piece of flagging there. That would be the center of the circle. And then you would use a measuring tape or some other way of accurately measuring the distance to the 10th of a foot out and swinging that tape all the way around in a circle, the extent of that circle would represent everything you wanted to count. So in a case of a purely a tap count, you would measure every tappable tree within that plot. And you would repeat that multiple times throughout the stand and throughout the property. And you would multiply that by whatever factor. So if you took fifth acre plots, you'd measure every tree in that plot, multiply that answer by 5, and then you would divide by the number of plots that you did. Same thing for 1/10 of an acre. If we measured every single tree in that 10th acre plot, then we would multiply that by 10, and we would get an estimate of how many trees or taps per acre there were. Plot sampling is also called fixed radius plot. Typically, we'd be looking at somewhere between 1 plot for every 4 or 5 acres. If you sample more intensively, you might do 3 to 4 acres. It just means you're going to be getting more detailed data. It'll take more time. If you're paying a forester or someone trained to do this, it'll just cost more. But the idea being that the larger number of acres for each plot, you're going to lose some detail, but you'll still have a good sense of what's happening and how many taps you have. It's kind of all over the place as far as how much a forester might charge you. I would think, again, it depends on the property, access, all those things, but it might be $3 an acre to do plots. You really would have to talk to the individual consulting forester and see what they would estimate. And going back to the idea of establishment of permanent plots, this is another way where you could put these plots in, you could actually number those trees, and over time you could keep going back to those trees and remeasuring their diameters, and you would get a sense of how growth rates are. And if you combine that with some of the information out of the Proctor Center in terms of growth rates and sustainability, you could get a really good sense of is the tapping intensity that you're practicing sustainable over the long term, or are you going to start running into an issue of hitting non-conductive wood and losing sap production? The third type of sampling would be what's called point sampling or variable radius sampling. And this is when you establish points similar to a plot sample, but instead of measuring a diameter, you use a tool to sample, and trees are counted based on their diameter and the distance from the point that you established. So we'll talk about the tools needed to do that sampling, but just understand that you're not measuring a diameter of a circle in this scenario. You're just navigating to the points that you've decided to have for your sample points. You're using your tool to measure the trees to see whether or not they are to be counted or not, and you're moving on. It's fast, much faster than plot sampling, and they can be accurate, assuming that people use the correct tools and know how to do it. There is some helpful information available. If you want more, I can help you with it. We'll talk a little bit about how to use the tools, but it is a little bit more than the time allows tonight to train you on how to do this type of sampling. What's really important, and this is true of point sampling or plot sampling, is that these points need to be located without bias or randomly. And by that, I mean, if you always put your points on that nice woods road that you always like to walk down, you're going to get a good sample of what the trees are around that nice woods road that you like to walk down, but it may not be a most representative sample of the trees you have in your woods. And as much as we think we can control our bias, it's difficult. And so using some of the free software that's available to randomly put points down on your property map, that can help you eliminate some of those biases. Even just walking uphill or downhill can influence where you put your point. So just one last thing to say is, if the goal is to get a real accurate count of how many trees you have to tap, it's important to make sure that you're sampling the entire property, not just the areas that are easy to walk through or are easy to get to. That's all I'll say about that. Like I said, you can put in more plots, but it will take more time or cost more if you're hiring someone to do that work. Here's another way of envisioning that variable radius plot concept. So let's say that red X is the point center, and you're standing there and you're measuring the trees in that location. You're going to use one of the tools that I'm going to describe in a little in a minute, and you will look around that whole all the way in 360 degrees around that point, and you will measure to see if the trees are tallied or not. And they will become more likely to be tallied the larger they are. So larger trees are more likely to be counted, but that just means that it's how the tools are designed. I'll talk about that in just a second. To be consistent, it's really important to start at the same point. So you want to start at due north and work your way around. The convention is to work clockwise around in a circle. You don't have to measure out the plot in these point samples, but you do need to make sure you're not counting the same tree over and over again or multiple times. So use some sort of landmark or some sort of identifiers so that you know you've come back around to the starting point when you're working your way around in a circle. The important thing is that you're standing right above that point center. You're not walking out to those trees. You want to make sure all those trees you're measuring are happening right from that plot center. I will say the last type of inventory is sort of a quick and dirty, and that is just to visualize a football field. So a football field is just about an acre in size. Most woods you can't see the equivalent of a football field, but you can probably estimate how close, and that would be another way to do it. Real quick and dirty, jump in there, decide whether or not you can see roughly half a football field or maybe a little more. Count the trees, and that'll get you on your way. Like all quick and dirty things, they'll get you a little bit of information, but it's not going to be the most accurate by any means, and it could cause you to make some choices in terms of buying materials or hiring installers or any number of things that you may wish you had done a little bit more high quality inventory. So what tools are we going to use? We have a couple of forestry tools that are pretty common, diameter tape or a Biltmore stick. These are ways of measuring diameter. You have an angle gauge or a prism. These are ways of determining whether or not a tree is to be tallied or not. A measuring tape, this would be like 100-foot or 100-meter tape. That's what you would use to determine if you were doing plot sampling, how far is that radius? How big is the plot? Am I going to do 1/5 of an acre? Am I going to do 1/20th of an acre? Whatever that is. Map and compass, still important, even in the digital age. It's really important to have a sense of where you're at, how to navigate to these data points if your phone isn't available or not working. And then a data sheet. Got to have a way of inventorying that data. A Biltmore stick is very simple. It's a wooden stick that looks kind of like a yardstick. It's designed with graduations along one side to measure diameter. You line up one edge of the Biltmore stick on one edge of the tree. You hold it a set distance away from your eye, and you look along the other edge of the diameter of the tree, and you see where that tree edge of the stem intersects with the diameter markings on the tree. They're in graduations of 1 foot or 2 foot, 1 inch or 2 inch, and they're not especially precise, but it does give you a ballpark number for diameter and probably precise enough for the purposes of measuring number of taps per tree. A couple of things to keep in mind. You always want to measure on the high side of the tree. Okay, a high side of the base of the stem. So if you're on sloped land, you're going to want to make sure that you're on that high side, not on the bottom or on the side. And you always want to measure at 4.5 feet above the ground. That's the forestry convention for diameter at breast height. And this just allows for removing mistakes from tree to tree. So a more precise measure would be a diameter tape. Here's one that's divided up. On one side, it has regular length measurements, and the other, it has diameter. And the way it works is it takes circumference and it does the math and converts it to diameter. So here's a diameter tape measuring in this case, a cookie of a sugar maple tree, and it's almost 11.9 inches, but it's just a little under 11.9, between 11.8 and 11.9. If you can see the bottom part of the tape, there's a line, and I'm lining up my eye with where that bottom line and the graduations above. And this is divided up into tenths. If you're using a D tape, make sure the tape is level, parallel with the ground, or perpendicular to the stem. It's not up or down in some way, and not twisted, because that would impact the measurements. So that's measuring diameter. You also have point sampling tools and plot sampling tools. So an angle gauge is an inexpensive way of point sampling, and you basically look through that oddly shaped opening in the angle gauge, and you look to see whether or not the tree in question fills that space, that little void, or not. And there's a couple of different. There's a 5, a 10, a 20, and actually even a 40 factor. Let's go to the very top, and that's the 5. So if a tree totally fills that slot, that's the width by the 5, then the tree would be counted. If it doesn't fill that, if you can see daylight on either side of the tree within that slot, then it isn't counted. And you rotate this around plot center or point center, and that chain is meant to set the distance away from your eye. So you would hold that either up to your mouth, or some people would actually put it in their mouth, but it's probably not tasty to chomp on that. But you want to make sure that distance is kept constant as you're rotating around the plot, and you're counting all the trees that are filling that void. A cheap and easy way, instead of using the angle gauge, is using a penny. That's similar to the 10 factor that was on that angle gauge. It's not exactly the same, so it would be it would actually tally slightly fewer trees, so you might do an undercount. In that illustration below, you can see the kind of penny, the view from your eye of whether or not that penny totally covers the tree diameter or not. And if it is equal to that diameter or greater, then you would count it. And if the penny is larger than the stem, you would not count it. And you would repeat this for all the number of points that you had decided was appropriate for your stand. A more expensive but more precise way of doing point sampling is using a wedge prism, and this is a well-engineered, carefully engineered wedge of glass that you look through. And the angle of that glass, it has a set angle, and that does a certain amount of offset. It makes the view through that prism slightly offset from what you see above and below the prism. And depending on if the offset overlaps or is completely exposed, would be whether or not you tally the tree or not. That's a little abstract to say in words. This is an illustration of what it would look like. The tree on the left in this illustration would be out because it doesn't overlap. The tree in the middle clearly overlaps and would be counted as a tree. And the tree on the right is right on the borderline. It's really hard to tell. There's different conventions about what to do in this case. Some conventions would say treat every other one, count every other one. So you just have to keep track of whether or not the last one you counted in, and then the next time you have a borderline tree, you would not count it. So if you're taking that extra step of understanding the diameter distribution of trees, you would go out to all the counted trees, the trees like in the middle that are clearly overlapping, and you would measure the diameter and you would record that. One other thing, actually, we can go to this. This is in reality, this is what it looks like when you're looking through a prism. You can see the center of the stem is offset, but it is clearly overlapping above and below. So this would be a tree I would count. Remember, When you're doing point sampling, it's really important that you establish that point center right away. Put a stick in the ground, put some flagging there, something that's not going to move, because even just a little bit of movement side to side or front and back can make the difference of whether or not a tree is counted or not. And the same is true for a plot. You don't want to be moving plot center around, because just a little bit of difference can impact whether or not a tree is counted, and it'll just make your data inaccurate. Data sheet, very important. You want to record that data. You can make your own data sheet. It doesn't have to be complicated. You do want to make sure you're keeping a tally of how many tappable trees. If you are looking for potentially getting a loan, they're going to want to know how many taps per acre there are on this property, because that's going to impact your ability to produce sap, syrup, and in their mind, pay back the loan. So really important to have good numbers on this. The stands are important because you want to be able to compare, what stands have the good density of trees and which ones are maybe a little thin. And you also want to make sure you write down what the plot size. If you're doing fixed radius plots, you want to make sure you know what size plot you're doing, so you can do the math on estimation of trees or taps per acre. So here's an example. You can break it up by diameter class. In forestry, it's a little odd. There would be a range in diameters. Generally speaking, it's a 2-inch diameter class. So if you say a 10-inch tree, that is the 10 inches is the center point of a 2-inch diameter class. And so it could go everywhere from a 9-inch tree to an 11-inch tree, and so on. So it can be embracing the forestry methods might be a little confusing. You could do your own data sheet, make up your own diameter classes, however you want to do it, but make sure you're having a space to tally the trees that are in, and knowing what size plot you're using. If you're using point sampling, and you can find this information online as well, there's a multiplier, some sort of a factor to estimate how many, based on whatever factor prism you're using. The prism that are most common would be a 10-factor prism, but you would have a multiplier, so multiplying whatever number of trees you tallied in that various diameter class, you would multiply by that factor, and then you would total up for number of taps per acre. Developing something consistent, a data sheet that will work for you, is important. Make sure that whoever is doing this work has thought through, what stands they're going to do, how many points they're going to do, how they're going to navigate to those points. And that is what I got for you. So there's a fair amount to cover there, and hopefully you got something out of it. And I'd be happy to take some questions now. I can stop sharing, and I will try to give everyone a chance to.
And Mark, this is the other Mark. I'm just gonna chime in and read one question off the chat box.
Sure.
And then I can start unmuting if you want.
Okay.
Question came in a few minutes ago. I think this was right before you went to some of the point sampling techniques. What about CIR, color infrared imagery, to determine type and size for a method of inventory?
Yeah, that's a good. That's pretty high tech. There's definitely some remote sensing that can be done to look at species. Obviously, it would have to be when the leaves are on. I am not that familiar with that technology, so I wouldn't be able to estimate. I think it could probably give you a good sense broadly of what percentage in your stand are maple versus not. But without getting on the ground, it's hard to do diameters. And I know LiDAR, which is also a modern remote sensing technique, has come a long way. They're not there yet in terms of measuring diameter from that far away. So I would still say that someone has to be on the ground measuring those trees. So I think everyone now, I think I gave everyone permission to unmute. So if anyone else has questions, I'd be happy to happy to take them there. Or if you want to contribute, how you're approaching inventory at your own property, or issues that you've run into in terms of measuring trees. Love to hear it.
Hi, Mark. It's Jenny from Ontario. Thanks for the great presentation.
Hi, Jenny.
Hi. So I just had a quick question about, you mentioned earlier that some trees might not have fully functional DBH, and that could also be included in the inventory. Do you have any tools or tips for how to do that?
Yeah, I mean, it would be the easiest would be just to estimate. You look at an individual tree that has a big, area of decay that's visibly, non-conductive. You would have to make some sort of estimation. Okay, is it 20% of the tappable area, and just reduce it proportionally. The individual tools, I mean, we can't see inside the tree, so it would have to be a really visible defect for you to make that sort of deduction in terms of functional diameter. There's some question about, what's the maximum capacity of sap flow through a certain unit of wood. So like that, for instance, that sugar maple borer that I showed you, that's a big proportion of the tree's circumference. And under sort of gravity sap collection techniques, you would expect that the reduction would be significant. But with high vacuum, we don't really know enough at this point to say, would you see as a dramatic reduction? I think it's safe to estimate that yes, you would, and to make some sort of reduction. And I don't want it to suggest that you do this for every individual tree, because it would take too long. I guess I'm bringing it up because if you have a stand that has a lot of issues with decay, it's worth noting, it's worth considering, and making some reductions. But also, those might be good candidates to remove and maybe put the limited sunlight that's out there onto trees that have a better chance of living over the long term and putting on new growth.
Awesome, thank you.
This is Mark Canella. I'll just remind folks, feel free to, should be able to unmute yourself if you go to your permission, look at the little microphone, and if you're more comfortable typing into the chat box, don't hesitate to type in a question there, and I'll be sure to read it if the other Mark doesn't read it right away. Mark, I'm just going to ask one question if I can. A lot of times coming back to yield, to sap yield and overall sugar yield, I know we've got a great legacy of talking about yield per tap. And what I'm kind of understanding from this presentation is that really it's sort of changing the orientation from a tree basis to an acre basis. And I'm just curious if you have any thoughts about, when, as a forester, when you hear people talking about yield per tap, do you have any thoughts about the potential or the merits of people considering their yield more on an acre basis rather than on a estimated tap level?
Yeah, I mean, it's dynamic because, at any one given time, you might have, a really high yield per tap. But over time, if you're not maximizing the growth of those trees, you are probably going to see that yield go down because the trees aren't putting on enough wood to make up for what's being removed from tapping, both the wood that's removed by the tapping process, but also the non-functional wood that accumulated over time. I think the yield per acre is an interesting idea. The silviculture, I would say, isn't totally settled. I think I alluded to it a little bit when I was talking about that older style of widely spaced, large crowned trees. But the issue with maximizing the number of, well, I think I talked about it, the maximizing number of taps per acre is that you might find yourself tapping smaller and smaller trees and not paying attention to tree growth. I'm not sure if that really answers your question, but yes, per acre is a good way of approaching things, but you also have to understand the underlying patterns or distribution of what size trees you have, so you don't end up in a scenario where you've tapped these same trees for years and you don't have regeneration coming to replace them, or you're at such a low growth rate that your yields go down and down and down because you consistently hit staying non-conductive wood. I think I saw a note from Nicholas. Is there a tree health classification like the MSCR in Quebec that you use to inventory the health of the sugarbush? Nicholas, I'm not familiar with the MSCR actually, but in forestry, there's definitely vigor and health measurements. It's not as common in a sugarbush inventory. Typically, it'll be a pretty simple, just what size tree and is it tappable. I think, much like Jenny's question about the tapping shell, or how much conductive wood is there to tap, I think it's really, a tap is not a tap is not a tap. Just like a 5-inch tree should not be added to the same bucket as a 15-inch tree. They just represent different potential in terms of yield. So an unhealthy tree, there should be a way of identifying and letting the landowner or the producer know what proportion of their trees might have compromised health. But Nicholas, I don't know how widespread that type of measurement system is in sugar bushes. It depends largely on if it's a property with a long-term forest management plan, if that is brought up in those documents. Thanks for your question.
Hey, Mark, this is Tony here. I had a question for you. I'm actually looking at a new property, and I've already done some sampling with the PRISM method. And so I've taken about 100 points, actually. And the average tap density I'm getting is quite high, about 105 to 110 taps an acre. And it makes sense because there's lots of small trees in polewood, right?
Right.
So it's right, the forest is just ready to start tapping, but it doesn't have any mature trees. Now, trying to take that, and then so if we look at what you were alluding to, yield per diameter, yeah, I can take the 110 and just multiply it by, 0.25 gallons a tap to get a yield. But, if there were big healthy trees, I'd get more sap per tap. So I'm trying to correlate, a smaller diameter size class forest with, let's say, the average expected yield. So all I'd have to do is, like, when I take that curve that you showed in one of your first, the correlation between sap per tap and the diameter, if I take those numbers, I get ridiculously high yields because they're like, I think it was 100 gallons per tap. It's just, out of it's like ideal conditions. So I'm trying to figure out, how can I make a factor that would account for the fact that my trees are smaller diameter?
Right. Well, and it's a good observation that those numbers are based on, ideal conditions. I would say that that you could discount by a certain percentage, take the average diameter for that stand, and you could, if you're measuring diameter, if you know how many in each size class, you could discount by a certain percent, and it might be in the 5% per inch diameter range. We haven't really worked out the relationship super strongly, but I'm guessing it's in the 5 to 7% per inch diameter range. As you go larger, you're going to get progressively more sap. So many factors could influence that: vacuum, intensity at the tap hole, sanitation. All those things are going to influence that. But the relationship, like in that graph that I put on earlier, shows it's fairly linear, but it's in that 5 to 7% per inch DBH range. And then the other issue is, management wise, if you have a lot of small trees, the temptation is to maybe remove some and try to pick the winners that you think are going to be the crop trees of the future. Depending on, again, without seeing the stand or seeing the stand data, it's hard to say, but It can be tempting to take out too much. There are a lot of things that can contribute to take small trees out of the equation, either natural dynamics or what have you. So it's good to flag some ones that look like good winners, but when they're in that really small pole size, it might be a little small to start doing any real pre-commercial type work to try to focus on the winners. Stem form is probably the biggest thing that you would use to decide whether or not to take a tree out. Let's see. Dave Mant says, knowing that the goal is to have at least 25% non-maple in the stand, should the inventory include non-maple stems to give one an idea of species composition and total number of trees per acre? Yeah, that's a great point, Dave. And it's sort of it points out that if you're just looking at taps, you're ignoring what else is growing there. Obviously, in a stand that's naturally heavy to maple, it's going to be mostly maple, but we know that there's lots of other species in the woods. So it would be a good idea to have a more comprehensive inventory and one that would align with other goals besides tapping, like long-term forest management goals. And keeping that diversity, especially, it's a requirement if you're certified organic. You would want to make sure that you are reaching that threshold. Good question. Any other questions? Appreciate everyone's time and attention and their questions. And there's a fair amount to cover. There are lots of resources. If you want to develop your own inventory method to get a little better handle on how to use the angle gauge, there are definitely some tutorials. Really rooted more in the forestry side of things, but if you have questions in the future, don't hesitate to reach out to me for help finding those resources. I would like to say that we're continuing this webinar series. We have in 2 weeks we have another one coming up, and that's on SAP only enterprises. I don't have the list in front of me, but I could pull that up.
I could pull it up if you don't mind. I just want to. This is Mark Cannell. I just want to thank Mark Isselhardt for a great presentation. Always great content and always presented well. The outlook as people start to get off. SAP Only Enterprises on September 15th with Chris Lindgren. The next webinar after that is Wednesday, September 29th. That'll be me having a discussion about binding contracts and binding legal agreements. Then on October 13th, we've got Dr. Tony D'Amato talking about maple forests and carbon. And then the initial calendar ends up on October 27th with a presentation I'll be giving with attorney Jess Phelps on Northeast forest land tax programs and tax abatement. Sounds like Mark has given a little bit of a teaser that there may be some add-on sessions later on in the fall. So we'll be watching in earnest as those calendar dates become available.
Great. Well, thanks everyone for tuning in. And if you know someone who missed out on tonight's presentation or some of the earlier ones in the series, we post them on the maplemanager.org website. And we also have recordings from last year's series. So go check that out for more information. And with that, I'll say thanks to Mark for doing the back of the house stuff, and we will see you all soon. Take care.
All right, good night.